Okay, good morning class.
Good morning, sir.
So today we're looking at the paper 2 that you guys have written, the June 2023 paper 2. Just see how far we got. Yeah. So we're on question 8.2. Okay, so in question 8.2 we are told that one of those lessons again where the board doesn't play along. We are told that chord AB, a chord AB of a circle is 10 centimeters long. Okay, so it's marked already. Let's align this chord quickly. Okay, it's 10 centimeters long. The course obtains an angle of 56 degrees at circumference. AOD is a diameter. If AOD is a diameter, okay, there's no angle in semicircle, as chord CD, neither is DB, it's joined there. Okay, but if you join it, those angles will be 90 degrees. So angles in semicircle. By making a suitable construction, determine the length of the diameter of the circle to the nearest whole number. So the diameter of the circle is twice the length of the radius, not so. So if I calculate the length of OD and multiply it by 2, I've done the job. Not so. So if I got 56 degrees there, then we know that angle O1 is equal to 2 times 56. Why? So angle at center equals 2 times angle at circumference. Okay. So O1 gives you an angle of 112 degrees. You all agree with that? It's 112 degrees. It doesn't look like 112 because that is an obtuse angle. Okay. And clearly you can see it's an acute angle as the diagram indicates here. Ms. van Schoor, are you taking note of this? For what you was you? Nothing. You must be busy with this. So this is 112 degrees. So we have a triangle looking like this now. We had 112. OB is what you want to calculate. And we have 10 degrees. And the length of 10. So which rule do you think we're going to use here? There has to be the cos rule. Can you see that? Otherwise we could have calculated A2 and then we could have used the sine rule as well. Okay? So I think in the memo I'm going with the cos rule, no? Just checking. Right. So what I'm going to do is I'm going to go with the sine rule instead. So if you have dealt with the cos rule, you can just check the memo out. The question paper and memo can be found in the description box below. Okay. So I'm going to calculate A2, but A2 is the same as OBA. Why? Because it's angles opposite equal sides, and it's your radius there. Okay. So twice A2 plus 112 is equal to 180. That is sum of triangles there. Again, you don't need this reason here, because we're not busy with a Euclidean geometry. Okay, since we are busy with trigonometry here, sine, cos and area rule, I don't need the reason. Okay, I'm just putting it here. Unless the question has said with the reason. Okay, which it didn't. Alright. So that's going to be 2a squared, 2a, twice angle A2 is equal to 180. Minus 112 minus 112, and then it's 68 divided by 2 is 34. 68, so A2 is going to be 34 degrees. Okay, so that is 34, and the other angle of course is 34. Okay, so now we say that sine of 34 over OB is equal to sine of O1, which is 112 over 10. Okay, which now gives us OB sine 112 is equal to 10 sine 34. So OB is equal to 10 sine 34 divided by sine 112. Put that in a calculator. So 10, it goes over 10 sine 34 degrees over sine 112. Gives you 6,03. 6,03, and of course the diameter, sorry, diameter 8. Okay, so therefore the diameter is equal to 2 times 6,03. You all agree with that? Pull this up here. So your diameter is equal to 12.06. But it says to the nearest whole number. So that's approximately 12 centimeters. Is that correct? Okay. Sorry about this here. As you can see, the board is not just jumping around here all over the place. I don't think he wants to work with you guys. No? You guys don't want to work with it either. No? Right, so we are told that in the circle, QT is or V. QT is or V. Center O. So if O is the center of the circle, we know that O1 is going to be double angle S1. Why? Because the angle at center is twice angle at circumference. And there's many things we can derive from that being the center of the circle. Okay. Then we are told that OR is parallel to TS. Lines are parallel, what do we know? We know that we can use corresponding angles are equal, alternate angles are equal, and co-interior angles are supplementary. So which means to say that O1 is also equal to T1. Okay? Then we are told that VT is the diameter of the circle. So if this is the, oh my word, if that's your diameter, then angle R1 and 2 is 90 degrees. Why? Angle in semicircle. No, not all. It's actually this angle here. It's actually this angle there. Okay. So VT is obtaining this angle here only. Okay. Then we are told that angle Q is 60 degrees. Go to first things first. Make it a bit smaller. Pull this up. So you need to align it again. The question says calculate the value of T1. But we know that T1 was equal to O1, corresponding angles. And we know that O1 is double. No. T1 is the same as 60. Why? Angles in that same segment. Okay, there's many lines in this diagram. So you must familiarize yourself with the diagram first. Okay. In question 1, T1 is totally 60 degrees. Why? Angles in the same segment. And it's coming from arc, you don't have to say this, but it's coming from arc VS. Okay. So I'm going to put 60 degrees here. Let's look at number 2. In question 2, they want you to work out O1. So O1 is also 60 degrees. Why? Corresponding angles. O1 is equal to 60 degrees. Corresponding angles with O. What's this? O? R is parallel to TS. Then they want you to calculate S1. S1. So here's S1. So here we see the angle at center is twice the angle at circumference. Not so. So S1 is going to be 30 degrees. The angle S1 is equal to 30 degrees. Why? Angle at center is equal to 2 times angle at circumference. Okay. Sure there's more to this diagram? Yep. So in number 4, they want you to calculate VRS. VRS, this angle here. But what we notice, that this is actually a cyclic quad. Not so. So what do we know? What's the relationship between the opposite angles of a cyclic quad? It is supplementary. So VRS is equal to 180 minus 60, which is 120. Why? Opposite angles of cyclic quad. Okay, this is getting worse, no? Opposite angles of a cyclic quad. Number 5. S4. So angle S4 is also equal to S, is equal to R2, corresponding angles. Okay, so that's not taking us anywhere. But S4 is also equal to that angle there, because that's the exterior angle of a cyclic quad. Not so? But that angle is also not marked. Okay? Then 90 degrees, yeah. I think that 90 degrees will come into play here somewhere. Here we can see that VT, that is 90, so I can go with angles on the straight line. Not so. So VS, what is this? What letter is here? VST. So VST is equal to 90 degrees. Why? Angle in semicircle. So S4 is equal to 180 minus 90 minus 30, which is 60 degrees. Why? Angles on a straight line. Angles on a straight line. Okay. So move to this diagram. No. So O2 given circle center O. If CD supposed to be BCD, no? Is center O with if CD is a tangent. It's actually EBA is a tangent. Okay, so that word is wrong there. Just change it on there. I'll change it on the copy again. But that's supposed to have been a tangent. It says prove the theorem which states B1 is equal to angle D. Which theorem is being proved here? The tan chord theorem. Okay. The link to the theorem can be found in the description box below. Okay. This is theorem 7, I think it is. No? One of the last theorems that was needed to be proven from the grade 11 syllabus. You can get this question worth 6 or 7 marks in your exam. Please know it thoroughly. Okay. In question 9.3 we are told question 9.3 we are told in the figure HK and HJ are tangents to the circle center. K and J are points on the circumference of the circle. The question says by making necessary construction prove that H, K, O, J. So then that construction needs to be made. It is a cyclic quadrilateral. So to prove cyclic quads, you prove one of 3 things. You prove that opposite angles are supplementary, exterior angles equal to the interior opposite, or the bow tie, the converse thereof. Okay? But we know that that angle is 90 degrees. So HKO is equal to 90 degrees. Why? Radius perpendicular to tangent. OJH or HJO is also 90 degrees. The radius perpendicular to tangent. So since HKO plus OJH is equal to 180 degrees. You see it adds up to 180 supplementary. Therefore, HKOJ is a cyclic quad. Why? Because opposite angles are supplementary. So that means to say that all cyclic quadrilateral properties are evident now in this diagram. Okay. Let's go to 9.3.2. If KOJ is 120 degrees. What kind of triangle will HKJ be? HKJ be. You want to know what type of triangle will that be? Show all working and give a full reason to justify your answer. So firstly, if that is 120, let me just see which triangle they're referring to. What is this triangle they're referring to? Okay. So what I need to do is I need to calculate all the angles. Alright. So we know that angle H is 60 degrees. Why is that 60 degrees? Because it's opposite angles of Opposite angles of cyclic quad. Remember in the previous sum we proved that to be cyclic. Alright. Now we know that HK is equal to HJ. Why? Because it's tangents from common point or external point. Tangent from external point or common point. Which then results in HKJ being equal to KJH. Why? Because it's angles opposite equal sides. So this angle here will be equal to that angle B. So let's work out one of the angles. So twice HKJ plus 60 degrees is equal to 180. Why? Sum of triangles. And it's triangle HJK. So HKJ is equal to 180 minus 61, which is 120 divided by 2, which is 60 degrees, which is also equal to KJH. So what do you notice now? All angles are 60 degrees, which is also equal to angle H. So since that is the case, what type of triangle is this? Therefore, HJK is an equilateral triangle. Why? All angles are equal to 60 degrees. All angles equal to 60, if it's to say all angles are equal. In the memo, I think I worked with the radii, no? Just check there. In the memo, I worked with the radius. Did I go the same route? Okay, another way you could have done the same proof was by going to say that those two lengths are equal, radii. Since we got 120 there, then each angle here will work out to be 30 degrees. Okay, since that is 30, and then I pick up that 60 there, opposite angles of cyclic quad, and then 90, because that is 90, 90 minus 30 is 60 and 60. Then you also could have proved it that way as well. Okay, so this in geometry, as you know, there's more than one way of doing this, proving what is asked here. Okay, I think that is behind the calculator there. I'm just going to take the calculator away for a couple of moments so that you can just pick up whatever you need there. Okay. Also not forgetting that the question paper and memo can be found in the description box below. Okay. So question 10.1. Sorry? Right, question 10.1. We are told that in the figure O is the center of the circle. So if O is the center of the circle, what comes to mind? Central angle theorem, or angle at center is twice angle circumference, and many other things, okay, radii and things like that. Then O is the center of the circle, and okay, if O is the center of the circle, then line PQ or chord PQ is the diameter, then R2 is also 90 degrees, angle in semicircle. Then we are told that SRW is a tangent. SRW is a tangent, therefore R1 has to be equal to P1, and R3 is equal to angle Q, and so on and so on. Okay. Then we are told that SO is parallel to QR, which means to say that R1 is also equal to S there. Okay. Without even reading further, we can see now that there will be a cyclic quad. Why? Because of the converse of angles in the same segment. Can you see that, people? So all of those things should pop in our head at this point already. Alright. So let's go and we answer the first question. The question says in 10.1.1. Just going to pull this over. in question 10.1.1. You must prove that PT is equal to TR. So what does this look like? It looks like that, like either correspond as a proportionality theorem, or it reminds us of midpoint theorem. Not so? So if you look at this, we know already that PO is equal to OQ. Not so? Why? Because of the fact that it's your radius. That is given, that's your radius. Alright. So if I'm going to go with proportionality theorem, then I'm going to say that PT over TR is equal to PO over OQ. Why? Because of the prop theorem. And very important to say that OT is parallel to QR. But since that is the case, that would simply be equal to 1/1. Can you see that, people? If PO is equal to OQ, then it has to be 1/1. Which means to say, therefore, TP is equal to TR. That's one way. Alternatively, I'll start off with this here. If I use now the midpoint here. If that is the case, that's your radius, then I can say, and it's given that OT is parallel to QR. Why? Given. So therefore, PR is equal to, not PR, TR, or PT is equal to TR. Why? Because the converse of the midpoint theorem. So there you could have used any one of the two methods. You can either use the proportionality theorem, or we can use the midpoint theorem. Which one did I use in the memo? The first one, proportionality theorem. Okay. So also with that, I mark on the diagram that it's equal. Why? So at one glance I know what I've proven and what we have calculated at that point. Okay. Let's look at 10.1.2. 10.1.2. I think there's a W at the bottom, yeah? Don't forget. Just put the W here. So here the question says, why is angle T1 90 degrees? But we know that R2 is 90 degrees, as indicated before. Why is R2 90 degrees? Angled in semicircle. Now T1 is 90. And why is T1 90 degrees? Because of corresponding angles with OT being parallel to QR. Okay. Nobody told me, sir, thank you for an easy paper that you gave me this time around. No? Because there's nothing challenging yet. But let me know when it's coming. The challenging questions is coming, no? So there we have proven that's 90. Alright. Let's go to the next question, number 10.1.3. The question says, prove that OPSR is a cyclic quadrilateral. OPSR. OPSR. Okay. But we spoke about that already, not so. So where do we start? We can say, let angle S equal X. If angle S is equal to X, which are the angles equal to X? R1. So angle R1 is also equal to X. Why? Because it's corresponding angles. Can you see the F being formed there? With OS being parallel to QR. Okay. But we know that angle P is also equal to X. Why? Because of the tan chord theorem. Tan chord theorem. So what we notice, those two angles are equal, so we say since. We state the obvious, since angle P is equal to angle X, which is equal to X. Therefore, P is RO is a cyclic quad. Why? Because you can either write converse of angles in the same segment or equal angles subtended by chord, or the same chord. Okay, I think that's also behind the calculator there. So we'll take it away. Okay. So now all cyclic quadrilateral properties are evident now in that quad there. Okay. I'm not going to draw a circle around it because I don't want to overpopulate the diagram. There's two more questions here, so let's pull this up a bit. .1.4. Let's take this off here. As everything I have calculated already or proven, I've put it on the diagram. You guys will make that a habit as well, okay? So 10.1.4, we must prove that. So I start by saying in triangle STR and triangle PTO. Most of the time the order is given properly, if not all the time in the exam. So let's look at the cube triangles in question. S, T, R, yes, and P, T, O. So what can we say here? We already know that that angle is equal to that angle, not so? Then we know that that is vertically opposite there, not so? And the third one has to be equal. Why? Because why? It's the third angle in a triangle. That was an easy one, huh? Sorry about that. Making it too easy for you guys. So we're going to say that angle P is equal to angle S, which is equal to X, proven above. Okay. Then we know that T1 is equal to T3, which is equal to 90, vertically opposite. We don't have to say the X, you don't have to say the 90 in this case. So therefore, O1 is equal to angle R3. Why? It's the third angle of triangle. If two angles of a triangle are equal, the third one has to be equal. Okay. So therefore, STR, triangle STR is similar to triangle PTO. Let's see if the order is in the right, letters are in the right order. So it's T, ST, so it must be P, yeah, it's correct. Why? Angle, angle, angle. That's the only way you can prove similarity if given angles. If you're given sides, then you prove the sides are in proportion. Let's look at the number 5. Question 5 is calculate TR. Leave answer insert form. If OT, so very importantly from here people, we know that most of the time after a similarity question, a distance question follows. So we say that ST over PT is equal to TR over TO, which is equal to SR over PO. Why? Because triangle is TR is similar to triangle PTO. So let's look at S. So if you look at OT, OT is 1. So I can calculate a QR if needed. It's going to be 2 because of the midpoint theorem there, but it doesn't look like I need that. Then TS is 7. TS is 7. Okay. So we got 7 over. They want you to calculate PR. 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 Which is this length here. So if I can calculate the length of PT, if I can calculate the length of PT and double it, then I've done the job. Not so. I'm missing something here. That is 17. OT is 1. Sorry? PT is equal to TR. Yes, I know that. Oh, yes. Sorry, man. So, TS over PT is equal to TR, which is also equal to PT, not so, over OT, which is 1. Right. So I just overlooked that thing. So you cross multiply. So PT squared is equal to 7. So PT is equal to the square root of 7. Is that correct? Right. I think that was a nice question there, got me thinking. Yes? Oh yes, and I must double it, no? Yes. So therefore, PR is equal to twice. Why? Because the diameter is equal to twice your radius. Okay. You don't need the reason there again. No? Is this geometry already? Yes, so you need the reason. 10.2. In question 10.2 we are told, in the diagram BC is your diameter. So if BC is your diameter, what we know? D1 and D2 is 90, E3 is 90 degrees. D3 and E3 is 90 degrees. BD by 6A BC, which means to say that angle is equal to that angle. Okay. Prove the following, stating all necessary reasons. That's 1, 2 questions there. So we must prove that BE, so let's see which BE, yes BE, sorry about this now. That's the length they're looking at. EB, BA, which is the whole length, BF, this length here, and DB. So clearly I can see which two triangles I need to prove similarity. Okay? It is in triangle FEB and triangle DAB. I know B is on the right place, okay? So that's going to be a common angle. So we're going to prove similarity. Remember that this comes from the two triangles that are similar. So we start by saying that B2 is equal to, B2 is equal to B2, or B2 is a common angle in the two triangles. You don't just write common. You must write either common side or common angle. In this case, it's common angle. Then we need to prove one more angle is equal. Okay, one more angle is equal. So I know that E3 is 90. Okay. D3 is 90. Which makes the combination of D1 and 2 also 90. Angles on a straight line. And this is my second angle that is now equal. Can you see that? So we go with that one quickly. We say E3 is equal to 90 degrees. Angle in semicircle. And then D3 is 90 degrees. Angle in semicircle. Okay. Then BDA. Or I could have said D1 plus D2. Or angle D1 and D2. All of that is going to be the same thing. It's also equal to 90 degrees. Angle on straight line. Angles on a straight line because it's just written straight line. So therefore, E3 has to be equal to ADB, which is equal to 90. Proven now, no? And then the third angle, of course, has to be EFB, has to be equal to angle A. Why? Because that's the third angle of triangle. Okay. So therefore, triangle FEB is similar to triangle. So F corresponds with A, E corresponds with D, and B corresponds with B, of course. Why? Angle, angle, angle. Okay. So from this we can now conclude that FE over AD is equal to EB over DB equals FB over AB. So what are they looking at? They're looking at BE, they need that there, AB, FB and BD. Can you see that? So I cross multiply them. Okay? So we just conclude therefore EB times AB is equal to BF times BD. Or they could have asked you to prove that EB over AB is equal to BF. No, not that. It's actually this what I was trying to show you. They could have told you that to prove that EB over DB is equal to FB over AB. You go through the same notion. Okay, but they just took it a step further. Okay. So at this point we have proven that these two triangles are similar. Okay. So let's take this off here as I need space again. That was in question 1. Let's look at question 2. Question 2 says, prove that D is a tangent to circle. So DE is a tangent to circle through EFB. So the question you should be asking yourselves, if this was a tangent, then what could we have concluded? We could have concluded that B2 is equal to E2. So in order to prove that it is a tangent, I now prove that B2 is equal to E2. Okay. Just take us away as the diagram is overpopulated here. So firstly we can say let. Did I use an X already? Yes. So we can say that this angle here, B2, is equal to B1. Why? Because we are told that the two, DB is bisecting angle B. Is that correct? Right. And then B1, of course, is equal to E2. Because that's angles in the same segment from chord CD. So therefore, E2 is equal to B2. Okay. So we say that firstly B1 is equal to B2. Alright, how do we know that? We know that it was given that BD bisect ABC. Okay. Then we say that B1 is also equal to E2 because there's angles in same segment. And it's coming from arc CD. So we say, since we're stating now the obvious, since E2 is equal to B2, therefore DE is a tangent through circle FEB. Why? You can either write converse of tan chord theorem or angle between line and chord equals angle in the alternate segment. Okay. That is 3 healthy marks then, eh? Healthy, for some of us, would have been the difference between an A or a B, ne? Come 6 or 7. Or pass and a fail, ne? For others. People question 11. The diagram shows triangle ABC. Okay, let's just check if everything's still in order here. Let's hope so. Right. So it's the triangle ABC. Then we are told that D, K and E, D, K and E are points on the sides of the triangle. So we put what's this 11.1. The question now reads, now we are told part of the information is that AD, so AD over BD is equal to 2 over 3. Okay, I prefer working in ratios, okay? In fractions, I know some of you can work in ratios, no problem. So AD is 2K and BD is 3K. Also to remember that you can't write 2 and 3 because there's not 2 and 3 units. Okay? Then BE over EC is going to be 4 over 3. So BE, so that's going to give you 4A and CES 3A. Okay. This loose? No. Okay. Then we told that CD and AE intersect at P, which is that in the point. Then we are told that DK is parallel, so we know that all the sides, the corresponding sides are in proportion and all of those. Right, number 1. Question 1. Determine the value of CP over PD. But CP over PD is the same as CE over KE or EK. But what don't we have? We don't have KE. So I must calculate KE first. Not so. So now, look at this triangle here. You can say that BD. No. You can say that DA over AD over AB is equal to KE, and that's what I need. I'm picking up that, and this whole length of BE. The proportionality theorem with DK being parallel to AE. Why did I not go with BD? The reason why I didn't go with BD because I don't have that. Okay. I'm just going to take this lines off here. As the diagram is becoming overpopulated here. Okay. So what do we say? AD is 2K over AB, which is 5K, must be equal to, that's what we're calculating, KE over 4A. Of course the K's cancel, cross multiply, so EK is equal to 4A times 2 is going to be 8A over 5. So that's going to be 8A over 5. Or 8 over 5A. Okay. So now we can say, therefore, CP over PD is equal to, so CP over PD is equal to 3A over 8 over 5A. Again, it's the proportionality theorem. With PE being parallel to DK. Okay, I'm just take a calculator again away then. Okay. So this cancels. So that gives me an answer of 15 over 8. Is that correct? Okay, now next lesson. Now we can do this quickly. The last question says, just pull this on top here. In number 2, we are asked to calculate the ratio of BAE, triangle BAE is to triangle ACE. So how do we calculate the area of a triangle? Half base times height, half base times perpendicular. So that would simply be half the base here is BE, which is 4A, times the perpendicular height, whatever it is there, is to half the base here is 3A times the perpendicular height again, which is a common perpendicular. I divide by half, that cancels. I divide by the 8, that cancels. Divide by perpendicular height. So from here, the answer is simply 4:2. Okay. And that brings us to the end of paper 2. If there are any queries, we can sort out in our next lesson. Tomorrow we're going to start our lesson on probability. We will enjoy the rest of your day. Good afternoon, class.